So last week, I talked about how Venus is hell, which it is. And you don't want to go there, which you don't. I know some of you thinking like, yeah, no, I'm going to be a rebel. I'm going to go Venus. Just don't. Trust me. All right, you will be melted. Your face will get hit with acid rain. The pressure will crush you like an empty soda can. Like, it's just bad news. How did Venus get so bad? Obviously, we don't have the full picture because it's not like we can ask Venus. We can only put together some clues. And because Venus is about the same size, the same mass as Earth, it was made out of the same solar nebula, like we're born right next to each other. We're Earth and Venus are siblings. We are pretty sure that Venus had the same mix of stuff that Earth did. The same kind of oxygen mix and silicon and carbon and nitrogen, just the same general stuff that made the Earth also made Venus. And that plus computer modeling suggests that the early Venus wasn't so bad. That's right. Early Venus probably had liquid water oceans, probably had a nice nitrogen atmosphere, maybe fluffy white clouds, water vapor. It was a decent place. Maybe a home for life. I'm not going to go all the way there, but it could be. It could be. Maybe Venus wasn't so bad. Back in the past, we're pretty sure Venus was pretty nice. But what happened? How did Venus get so screwed up while Earth stayed nice? It's the sun's fault. It's always the sun's fault. See, back in the day, billions of years ago, the sun was smaller and dimmer. As stars like our sun age, they steadily grow brighter and they steadily grow bigger. Very slowly over the course of hundreds of millions and billions of years. So way back in the day, Venus was firmly in the habitable zone, the zone where it was just right for life. It wasn't too hot, wasn't too cold. But as the sun aged, that habitable zone got pushed further and further out in the solar system until where it is today, starting about 3 billion years ago or so, the Venus was like right on the inner boundary. So Venus started getting warmer because the sun was getting warmer. This caused its oceans to evaporate, put water vapor up in the atmosphere. Water vapor is a great greenhouse gas, so it started trapping heat. So the temperature on Venus started to rise, which evaporated more ocean water, which put more water vapor up in the surface, which trapped more heat, which caused the surface temperature to rise. And you get this positive feedback cycle where just once the temperatures reach a certain critical threshold, they just bounce off of each other where the temperatures just keep climbing and climbing and climbing until all the oceans are evaporated and all the water vapor is up in the atmosphere, and Venus is trapping heat as efficiently as possible. Means it's trapping all the heat. And now the temperatures on the surface skyrocket, go up to like 200, 300, 400, 500, 600 degrees, and then things just break down. With that, once the oceans evaporate, plate tectonics shuts down. See, the oceans help the process of plate tectonics. They're almost like a lubricant. They keep the ocean plates nice and ductile and flexible so that they can slip underneath and slip between each other, and they can keep this machinery of plate tectonics going. But with no ocean water, the plates get locked and plate tectonics shuts down. The water vapor that was in the atmosphere, sunlight hits it, breaks it up into hydrogen, oxygen. The hydrogen just floats away into space. Oxygen stays trapped for a while, and we'll get back to what happens to the oxygen later. But plate tectonics also does a very, very good job. It has another role. Plate tectonics helps maintain the carbon balance in the atmosphere. That's right, the carbon dioxide in the atmosphere is just a small fraction of all the carbon that's available on the planet. Most of it's in the dirt. And plate tectonics helps regulate the amount of carbon dioxide in an atmosphere, because the carbon dioxide will bind to like silicates, dirt, stuff and rocks. And then eventually over the eons, those rocks get buried and sunk down into the mantle. And then sometimes the carbon dioxide is released from like a volcano, or when a new plate forms or emerges, you get release and outgassing of carbon dioxide. So the plate tectonics is almost like the CO2 scrubber for a planet. It's always cleansing out the carbon dioxide. It's maintaining a nice even fraction in the atmosphere. But once you shut off plate tectonics, then slowly over time, you still have volcanoes happening. You still have just outgassing. You have vents here and there. You just have carbon dioxide molecules just leaking out here and there. So over time, more and more carbon dioxide makes its way into the atmosphere. It gets thicker and thicker and thicker. In fact, it looks like Venus, the rocks of Venus, the body of Venus has lost all of its carbon dioxide. Now it's all in the atmosphere. And so now the atmosphere is this super thick haze. You still have volcanoes going on, which are going to release sulfur. The sulfur is going to bind to that oxygen that was left over from the water and turn it into sulfuric acid, acid rain. Those will form the cloud tops. Now that you have this thick atmosphere, the thick atmosphere is heated on one side and cold on the other from its orbit around the sun, and it's thick enough to actually drag on the planet. Like the atmosphere is thick enough to rub up against the dirt, slowing the rotation rate of Venus. I should say there are a bunch of possible mechanisms of why Venus has a slow rotation rate. That's one. This is the worst part, though, of the story of Venus, of how the sun got too hot and it basically shut off this planet. Same thing's going to happen to Earth. The sun's not done aging. It's still getting older. It's still getting brighter. It's still getting hotter. The habitable zone in our solar system is still steadily marching outwards. Right now, we're still golden. We're still good. But that inner edge is approaching us. And in something like 300 to 500 million years, we'll be at that tipping point. We'll be at the tipping point where the solar luminosity will be so high that our oceans will start to evaporate, dump a bunch of water vapor in the atmosphere, trigger a runaway greenhouse effect, eventually boil all of our oceans, shut off plate tectonics. Our planet will dump all of its carbon dioxide in the atmosphere, and our solar system will have two hells instead of just one. I know it's a bummer, but what are you going to do? This is the universe. Thank you so much for watching. Don't forget to like, share, and subscribe. I really, really appreciate when you do that. And I also really appreciate when you go to patreon.com/pmsutter and keep this show going with just like $1 a month. That's all it takes. You can do more, but $1 is nice. And I'll see you next week.